Hi, Abu Bakr.
Hi, Rahul.
How are you?
Yeah, fine. How are
Good, thank you. We'll wait for 1 minute, then we will start.
you?
Okay, let us start. Um, can you hear me?
Yes, yes, Rahul. I'm able to hear you.
Oh, cool. Any questions so far? Whatever we have discussed?
No, Rahul.
Okay. You are from performance only, right?
Yeah, I'm from multiple background. I'm currently
Okay.
working in performance for 3 years.
Okay. And before this?
Before this, I was an automation engineer in backend, which is REST Assured API, and was worked on the framework
Okay.
and using Java. Uh, then I was working in Protractor. Now,
Okay.
in my current company, there is no guys for performance. My juniors, no one is there.
Mm-hmm.
So I picked this activity. So I was doing this completely,
Ah,
and
cool.
that's
Yeah, cool, cool. So you are liking it? Enjoying it?
yeah. I just want to move to performance. That's why I just wantedly pick this career.
Okay.
Yeah.
Um, Interesting area of software.
Yes.
Cool. So let us quickly recap what we have discussed yesterday. So we were discussing around about workload modeling, right? And the idea in a nutshell, workload modeling basically just to simulate the real world scenario. Okay. It is in a nutshell, but it is very, very important, right? So unless or until your designed scenarios are not replicating what actual user or actual application will behave, then running the test, providing those results, that won't solve our purpose, right? So we have saw one example how to drill down to per hour to if the application is an existing application, you should check logs. Okay, drill down your logs with TPH, transactions per hour, right? And make use of necessary filters. We have seen one query yesterday, right? So you can change few filters there, and we have saw that Gmail example now, right? Then you can use this little slow formula, number of concurrent user TPS into time. I understand since now people or applications are API based, right? And see, the fundamental will remain the same, whether it is an API or a UI flow, right? Uh, things will, I mean, the basics will remain the same. So here, this time is the total time, means the response time, think time plus spacing. It includes every thing. Okay. If users are given to you, well and good. If not, okay, you can do benchmark or baseline testing. Okay. The main important thing is throughput. So if you are aware of the throughput, TPH or TPS, then it is very easy to design the scenarios. Okay. So that is what we have discussed in detail yesterday. And now we are going to discuss about Java. Okay. So before coming to the main topic, I just want to say, see, writing a program, writing a code, or knowing how to do the things, that is becoming very less important nowadays, right? Because of AI tools, because of Chat GPT, you just give a prompt, you will get a full-fledged code, right? Even now there are many companies which are developing the whole software just with prompts, right? So the point is, how part is less important, what to do and why to do, that is getting more importance, right? So please remember this. So creating a program is not a concern now. We all are aware we can give some prompts to Chat GPT and can get code within seconds, right? The two most important things are why to do this, whatever steps you are taking. Okay, why you are taking those steps, and what steps you are taking. Those two things are uh, more important now. Okay. Now in terms of performance, when we talk about Java performance engineering, so let us see, there are three different terms you must have heard about Java installation or in general about Java program. The JDK, JRE, and JVM, right? Have you heard about these three terms? JDK, JRE, and JVM.
Yes, Raghav.
Yeah. So see, basically, JDK is a superset, right? Uh, let me Okay, so JDK means uh, Java is providing a tool to develop application, right? And JRE means providing us environment to run Java, and JVM means runs with it is an actual engine that runs your Java code. So everything comes inside JDK, right? JRE is a part of JDK and JVM is a part of JRE. Eventually, this all things belongs to JDK. Yesterday, you have seen one tool I was using, JConsole, right? So that is inside JDK folder. If instead of JDK, I would have installed JRE on my system, I won't get JConsole or JCMD, whatever tools are available to, do the analysis part, that will not be available. So tools are available inside the JDK part. Okay. So in a layman language, you can imagine it, JDK is like a full kitchen. Okay. Full kitchen means it has everything. JRE means kitchen with ready food setup, and JVM is your stove, gas stove, with on which you actually cooks the food, right? So JVM is like gas stove where you actually cooks the food. JRE means kitchen with ready food setup, and JDK means full kitchen. Make sense?
Yes, Raghav.
Yeah. So
Yes,
JVM is
yes,
the
yes.
engine. Yeah, JVM is the engine that actually runs your Java program. It converts your byte code. I'll show you live demo here. Uh, so we were working on this application yesterday, right? Yeah. So this was a program that we were running, right? Quick API, slow API, and CPU related API. Now all these things are inside .java class, right? Once you run this, .java gets converted to .class. Can you see this? Right? Now this is your byte code, okay, which will get read by your machine. So JVM converts your this dot class to machine code. Okay, so it is platform independent. Okay, platform independent, you must have known this thing. You can write once or run everywhere. The best example is Jmeter, right? Jmeter you can run on Mac, Linux, Windows, anywhere, right? So this is the best example. If you want to remember what is the meaning of platform independent, you need not to, you need not to change the code, right? You just write it once and you can run anywhere. It's just a matter of some different libraries that need to get integrated. Otherwise, the main program will remain the same. Okay. And JVM, like I mentioned, it has some other roles as well. And it is a very important part when it comes to performance engineering. So what other roles JVM plays? Let us see that. Yeah. So this thing, like I have shown you, there is a Java file, okay, which is a user readable file. Once you compile that code, it gets converted to .class file, right? If there is no error. This is called compilation. And then class loader will fix that. Okay, it convert into something which machine can understand. Okay, then it runs your code. So this is the actual engine. JVM is your actual engine, right? It also handles memory management. It also does garbage collection and the main thing, execution of code. Now let us see what is the architecture. When I say memory management, see, whenever you run your program, right, you need some space to store the data. Data means your program could have some local variables, your program could have some classes, and you are creating those objects. Whenever you run a method, then also you need some space, right? So all those space, all those memory management thing is controlled by JVM. Okay, please raise your hand or ask question if you have any doubt on this. So whenever you write a Java code, right, JDK helps you to compile it. That compiled code is called your bytecode. Then JVM executes that bytecode and JRE provides everything needed to run it. So in short, JDK is for development part, JR is for running your things, and JVM is for execution. Now let us come to and see how the architecture, when I say it does memory management, whenever you run program, you need to store those data, right? So how that memory of JVM looks like. So whenever your Java application runs, it needs memory, right? And JVM manages this memory in different areas. Each area has a specific role. Okay. Here you can see, if I focus on only this heap part, heap is also divided into different areas like hidden space, survivor space, old generation, right? Earlier, we were before Java 8 version, there was permanent generation as well. Now that is replaced with metaspace. Okay, so this is what I'm talking about. Earlier, heap space also includes permgen. Okay, but now after Java 8, that permgen is replaced by metaspace. Cool. Now thread area means each thread gets its own memory. PC is your program counter. Okay, sorry for this spelling. It tracks which line of code is executing. It is like a bookmark in a book. Okay, so PC means program counter is a bookmark. Which line of code is executing? Then comes the stack. It stores your method calls. It also stores your local variables. Okay, and every method call means every new stack frame gets created. Okay, I mean, this is the most important thing here. If you can also ignore this part just for performance engineering purpose. For performance engineering, heap is the most important area we need to understand. Okay, so heap is basically a shared memory. It is where object lives. Okay, whenever you create a class, whenever a object gets created of a class, it goes inside hidden space. So this is the first place whenever you run a program and objects gets created that goes inside hidden space. Okay. And if that object survives the garbage collection, surviving garbage collection means there could be something applications still require that it has to be remain in the alive state. Okay, that goes to survivor. Okay, now whatever objects survive these S0 and S1, those objects move to old generation. Okay, make sense? Any questions so far? So what I am saying is, let me quickly show you here. Yeah. So new object goes inside hidden space. Okay. And then garbage collection runs. Okay. Some of those objects survive these garbage collection. They goes inside S0 or S1. Then multiple GC cycles run. Whatsoever object survive those cycles, it goes to old gen. Okay. Now one question to everyone. What do you think? What kind of objects reaches to old generation? What do you think? What kind of objects survive all the garbage corrections and reaches to old gen?
Unused
My
method, like unused code.
sorry,
Unused code, like unused method.
unused unused
Mm.
method. Okay,
Which is idle for couple of idle for like couple of times. For example, it might have idle for not used for like 5 to 10 minutes, or just think it. Mm.
okay. Any real example of that kind of method?
Uh,
So first thing, I am here talking about an object. Okay, so yeah, so you are saying anything unused. Okay, that's fine. What do you think? What remains unused throughout your application flow? So for everyone's benefit, my question is, what kind of objects do you think reaches to old gen? Means it is surviving all the garbage collection cycles. Anyone? See, whenever you log in, right? Whenever you log in, what gets created?
a token,
Yesterday we were
token
talking about
yes,
bearer
yes,
token,
where a token.
right? Or you can say session data. It could be your bearer token. Okay, that remain alive until you log out. So whatever objects related to your session data, that objects survive all the GC cycles. Making sense? Yes, no?
Yes, yeah.
Yeah. So I'll repeat this point. All the objects related to session data, or it could be some cache, okay, it will survive every GC cycle unless you log out, right? So session data will get released when you log out from your application. Fine. Now another important thing I want to cover today. Why Java? Okay, why Java is widely used? So there are few. I'll quickly cover it. There are few advantages why Java is still widely accepted across different organizations. See, the memory management and GC tuning of garbage, I mean, of Java application is very good. Okay, JVM is very capable of handling memory management of garbage. part. So that is one advantage. Okay. It has better control over threads and resources. Okay. Also, we can do some deep insights into memory, like I was showing you on JConsole. We will also do some deep analysis of thread dump and heap dump in later sessions. But this is what I want to build the foundation. Okay, that's why I'm going through this theory part first. Okay, so multi-threading support. Okay, this is one of the advantage. Yesterday we were talking about concurrency, right? So Java application can give you good concurrency. Okay, reachable ecosystem. Like I mentioned, Jmeter is one of the example. Whenever something comes into your mind, platform independent thing, right? So Jmeter is the best example. Okay, so like we mentioned, it runs consistently across environments, supports clouds and containers, and enterprise adoption, banking, e-commerce, telecom systems, whatnot. Java is used everywhere. Okay, it works very well with Docker, Kubernetes, and you can create CI/CD pipelines. Profiling and monitoring is also very, I mean, since it is widely accepted, so all the tools are capable of do the profiling and monitoring of Java applications, right? So it offers visibility, control, and scalability. So that is why it is widely accepted and good in terms of your if you want to build some applications in terms of good performance, then Java can be one solution. Any question on this? Let me know if I'm going fast or slow, or is it fine?
Yep, it's fine. I believe.
Okay.
Most of the libraries has been built in Java. That's why it is more overused in the wider in the organization, right?
Hmm.
Even the rest,
That's right,
like
yes.
API. Yeah.
Okay, as soon as I share my screen, I lost my taskbar. I don't know. Okay. Okay. So, uh, so we have seen till now we have seen why Java for performance engineering and what is the difference between JVM, JRE, and JDK, and also the JVM architecture. Now I'll quickly show you how these GC cycles you can let me run a quick Jmeter test. Okay, so where is my JVisual VM? Has anybody tried whatever we have discussed? I mean, this demo load app on your systems?
No, no, I didn't try it. So did you share the like all the details, right? I didn't know. Probably I missed it or
Yeah, I have shared, yes.
okay, probably I missed it or I didn't notice that. Is
No
you send it
worries.
to the email
So
or
I have the available on Google Drive and I
okay,
share link with everyone whosoever shared
okay,
their email IDs with me.
okay, probably I will check in Google Drive then.
Yeah. So here you can see, right, these up, down graph, right? So this is called energy. Okay, so whenever you see, okay, first let me tell you what is this. So this is the heap. Okay, this is heap. And if you see currently demo load application, PID is 2072. So I am connected using Visual VM. And this is the heap space. This is the meta space. Okay, so heap like size, how much it's being allocated, and maximum I can go to till 1 GB. So if you remember, in our Maven command, we have given this, right? So it can go maximum to 1 GB. Okay. So these uh, up down graph you can see here. So these are minor GCs happening. Okay. So whenever memory shows this pattern, so that means it is a healthy sign. Okay, so see, from this time till this time, I didn't run any test. Okay, I didn't run any test, but still there was some allocation was going up, and it was the duty or it was the responsibility of JVM to release as to run the GC and to release the memory if it is unused. Okay, it is coming back to this. Okay, again it is going up, coming back to this, right? So this memory management is done by JVM. Okay, this memory management is done by Java Virtual Machine. And here we ran small test for 2 minutes. And here we could see there are minor GCs happening. Okay, minor GC is a good sign. Frequent minor GCs is a healthy sign. Okay, there should be less or no major GCs. Okay, anybody tell me why? What problem major GC can cause? Can anyone tell me? No one. So basically, major GC can in performance engineering we call that scenarios stop the world. Okay, major GC can stop the world means it can pause your application. It can hang your application for that particular moment. Okay. Now that moment may be few seconds, and that could be few minutes, depending upon how much um, heap memory is being already utilized. Right? Making sense?
Yes, so that means like suppose if all that during that time, right, all the transaction will go slow, right? Something, right? It will response time will go high, right?
Yes. So your application gets stuck.
Yeah.
Okay. You won't be. It's like a state. Okay. You won't be able to perform any action. So
Okay.
there will be timeouts.
Okay.
Yeah. So there will be timeouts, and unless or until that major GC gets completed, you won't
Got
be
it.
able to perform any operation on your application.
Okay,
But it is,
then it should not
yeah,
emergency should
yeah,
not
go
be
ahead.
happen, right? Otherwise, it will
Yes,
show you all the
correct,
error and everything.
correct. Major GC should not be happen. That's right. So that is why I was saying frequent minor GCs are a healthy sign for your application. Okay. Now coming to this part again. So we were discussing the new objects come to hidden space. Whatever survives all these GC cycles, they go inside all generation. And we discussed one of the example like session data. Okay. Now what is metaspace? So like I mentioned, after Java 8, it is the permanent generation is replaced by metaspace. So metaspace is a separate area from heap. So here also you can see that, right? It has nothing to do with my heap allocation. It is a separate area. Actually, it is utilizing the native memory. Native memory means it is utilizing memory of my system, memory of my laptop. Okay. So the role of metaspace is it stores your class metadata. It stores your class definitions, method informations, and static variables. Okay. And like I mentioned earlier, please remember this. It does not utilize your heap area. It uses native memory. So that is why this particular number or figures you can see there is no relation. Okay. Is that clear?
Yes, yeah.
Oh, okay. Any questions so far?
Soft, no, no.
Okay, fine. So let us see. Now I'll show you some examples here. Okay. Now I was saying all those static variables go inside metaspace, and all the method calls and local variables that go inside stack, right? So what is the meaning of local variable and how it is different from an object? Okay. See, this is called a local variable. Whatever defined inside a method is a local variable. Okay. And this comes inside under class. So this will go inside heap. Okay. So whenever something is declared within a class, it will go inside heap, and anything declared within a method, it go inside stack. Make sense? And string is a special uh, has a special criteria. It also go inside heap. Okay. So whenever you create a string s equal to something, it will go inside. It will take space of heap memory. Okay. But your local variables go inside stack. Okay, now, yeah, this is one of the example that I want to show you. Here you can see we have an employee class and then we have a static variable, right? So what will happen here in metaspace, like we were saying about static variables, right? In metaspace, the method information and this static integer and also the class structure, only the structure that go inside metaspace. Whenever you create an object of that class, so here I am creating an object of employee, it will go inside heap. Make sense? In metaspace, the structure of this class and this static variable will go inside metaspace, but whenever you create an object, it will go inside heap. Okay. The reason I'm emphasizing on this part, because in later session we are going to do some hands-on, okay, wherein we will create some faulty codes and see how that is going to uh, give us out of memory exceptions. Okay. If some developer misuses the places of these static, okay, it can create a problem. Am I making sense?
Yes.
Any question on this? Okay. So let us go back here. Yeah. So this thing we have seen, right? JDK, JRE, and JVM. Now, till now, we were working on this demo application, which was very simple. It has 3 endpoints, right? Now we are going to build a bit complex application. Okay. And we will see how that application, and we are going to deploy that application on Docker. Okay. So first thing, before creating that application, can anybody tell me what are 3-tier architecture? Have anybody heard about this term? 3-tier, 2-tier architecture?
Yes, it is like application layer, server layer, and the web server layer, and then database layer, right?
That's right. Yeah. So this is a typical 3-tier architecture application looks like. Okay. The first layer, like you mentioned, it's a web server layer. Okay. The main thing of web server, or the main role of this web server, is forwarding your request, load balancing, or it could be reverse proxy. The second thing is application server. This is the most important area where your business logic resides. Okay. Suppose you have wrote an application or you have created anything. So the logic of that application resides inside application server. Then the database layer. Okay, that is known as DB server. Okay, every layer has its own functioning. Like we said, web server could be your load balancers, or it could be do your reverse proxies. Application server is the main heart of your three-tier architecture. Okay, it contains all the business logic part. Okay, and whenever you monitor CPU memory, whenever you monitor your things, those you are going to monitor of application server. And the last part is database server. Fine. So there are some prerequisite. I will recommend you to install this Docker desktop if you are working on Windows system. This Docker desktop, install it on your system. Okay. So what we are going to do, uh, yes, this one. So here you can see this is Nginx app and database. These three are corresponding to these layers that I have shown you here. Okay. Have you heard about this word earlier? No. So Nginx is
Yes,
like a.
yeah,
Okay, you have
we did
heard.
have.
That's good.
Yeah.
Okay. Any idea what is this?
It's just like web server, like is it there is like some Apache or
Mhm.
some cases we have Apache, right? Something like the Apache.
Yep. Yeah. So it is a web server. It, like I mentioned, it is used to forward your request.
Yeah.
Sorry. Yeah. So we have three different layers here, and we have created three different programs here. The one is for Nginx. Okay. This is the setting for Nginx configuration. The other one is our application server. This is the important part where, like I mentioned, your application code resides, right? And then we have the database. So for this particular upcoming sessions, we are going to use Postgres. Okay, so this is the sign of Postgres database. Okay, and we are going to deploy all these things onto Docker. So here you can see I have one perf demo parent container which has all these containers. So currently these three containers are important: app, database, and Nginx. Rest other containers we will see later when we go to other sessions. Basically, other containers are related to integrating your Grafana, okay, creating graphs. So for all those things, we need exporters. So we will talk about that later. But currently, you need to understand these three areas: application server, web server, and database server. Okay. So whenever I am going to hit now, my hit, I mean, my request will go first to Nginx. Then that will forward my request to the application server. Then that request, whatever is written inside it will get forwarded to database server, and then the data gets fetched. I'll quickly show you what we are doing here. Any questions so far?
Oh no, I'm good. Sure.
So this is the simple endpoint. So what we are doing here, like you create JDBC connections, right? Similar thing, we are fetching some data from our Postgres database. Okay, there are three different uh, things: ID, amount, and status. Okay, so we are fetching this data from Postgres database, and whenever you hit this API on your browser, you will get the result. Okay, so this database contains currently 15 rows. Okay, it could be 15, 1500, anything. Okay, so currently I have inserted total 15 rows inside my database. Okay, so first thing is ID, then amount, then status. So whenever I run this pay endpoint, whenever I run this pay endpoint, it will run select query in the backend. That select query will go inside this database, and whatever, suppose if I am giving pay ID equal to 7, it will give me this result. Okay, simple, right? And like I mentioned, every component has its own functionality to play. This Nginx, which is a web server, you can see here we are setting upstream app server 8080, right? So whatever it, I mean, it will do, we are mentioning here. Then we have application server where the actual code is written. Okay, then we have database server. Now you need docker compose.yaml. Okay, like in earlier thing, we were using pom.xml, right? If you remember it. So we are going to deploy this application using Docker. So you need docker.compose. So in docker.compose, you have these three things, right? App, Nginx, and database. So Nginx will contain all the information related to your web server. Okay, I am actually pulling this image from Docker Hub. Okay, so this is the volume I am pulling. Okay, don't worry. I mean, so it may be overwhelming at a very first instance. Don't worry about it. I am going show you everything in detail, step by step. So don't worry about it. Okay, so I'm just giving you a high level idea, what we are going to discuss in upcoming sessions. Okay, so basically, whenever I run Docker command, it will install web server container by reading the details from here. Okay, what kind of volume I need. Okay, from where it is fetching all these things? From Docker Hub. Okay, on which port it will set this 80 port. Okay, it depends upon app. So what does that mean? If my application server deployment is okay, then only it will deploy Nginx. Otherwise, it will not deploy. And the one thing more I am here, networks. So I am making sure everything remain in the same network so that they can communicate. Communication is very important. Okay, so if you look at these three layers, these three needs to communicate with each other, right? So I am making sure all these lies in the same subnet or in the same network, right? Then we have application server. So if you expand this, so here you will find it depends upon database. So once database is healthy, then only it will deploy it. Okay, so it is checking whether database condition is healthy or not. If it find database condition is healthy, then it will start deploying application server. Okay, so all these things which we were doing earlier using Maven command, all these parameters are given here, right? This is my heap space. So I am allocating only 256 MB. Okay, what ports I am going to expose, since it is a Spring Boot application, so 8080 port, right? So this thing, right? So I am making everything inside a same network. Now coming to database. So this is the image of database I am pulling from Docker Hub. Okay, I am giving it as a name database, username, password. Okay, this is the default port of Postgres. Okay, this is the default port of Postgres 5432. Okay, and I want a health check as well. So it will keep on pinging the database every 5 seconds. If there is any problem, then it will give me the status as unhealthy. Okay, now if you look at this, why I am giving this health check settings only inside database? Anyone? I have not given health check settings in app or in web. Anyone? I have discussed this. So the reason is, once I'll go to app again. So you have seen this, right? App is depend upon database condition, right? So if database is healthy, then only app server will become up and running. And once app is okay, see, I'm mentioning here, right? Depends upon app. Then only my web server is get up and running. Make sense? So we are going step by step here. We are making sure our database will get up first. Okay. And if its status is healthy, then only our application server will come online. And once that comes online and its status is good, then only web server will comes online. Any questions so far? I understand this is something related to development part, but it is important so that once you start deploying this application again and again by making changes, so it will be easier for you to understand.
So are what are we using for the all the like Docker things? Like are you using the AWS or the Azure
Currently,
for the
see,
container?
currently I am going to deploy on my system itself.
Okay,
Okay, so how I am going to deploy it? So simple, I go inside this folder. Okay, this is my folder where this setup is available. Let me go inside this. I'll show you. Be simple perf demo. Okay, here you will find this docker compose.yaml file, right?
yeah,
This docker compose.yaml file is important because this is the command to compose everything and build and deploy all your servers.
okay. So
So
it will
once
be
you
doing
run,
in the local, right? Not in the
yes,
not in
all
the like
local, not
cloud.
on the cloud, not in the
Okay,
cloud. Yeah, yeah, in the local. So
okay,
once
got
you run this docker compose up minus minus build minus d, what will it do? It will go inside this docker compose.yaml. Okay, then it will start pulling all those images from Docker Hub
it.
and
Docker Hub.
installing those inside in Docker as a containers. Making sense, guys?
Yep.
Or it is, yeah, I hope I'm not confusing here, or please raise your hands and let me know if anyone has any questions on this.
No, as of now, but the thing is like if we do this automatically, the container will be created in our local system and we able to see in the desktop, right? This
Correct,
Docker desktop. Hmm,
correct.
okay.
So let me show you quickly. Suppose let me first
It is.
remove it.
Can we get this Docker commands, like basic commands that will be very helpful? Like I know, like we
Yes,
can
yes.
get it
I
from
am
the.
going to share. Yes, I
Hmm,
am going to share everything
hmm.
on your Gmail IDs on the same Google Drive. You can find it there.
Sure, sure. Thank you.
Yes. Okay. So currently, if you see now, there is nothing, right? All my containers are gone since I have removed everything.
Yes,
Okay.
yes.
Now, once I start this Docker Compose up, okay. Now what it is doing, it is actually reading that Docker Compose.yaml file.
Hmm.
Whatever it find in that YAML file, it will create a container. Okay, see, now my containers are starting created. Okay, all
Yes.
containers are created now, and everything is inside under perf
Perfect.
demo, the parent one.
Okay. The parent
Make
one is
sense?
the parent one is the container, and inside the container it is created, or it is just a label where
Just
inside we are running
a
all these.
level.
Yeah. Okay. Sure.
All
Okay.
these are independent containers.
Okay.
Okay, since I am, yeah, since I am doing all at once from the same location, that is why it is showing like this.
Okay. Hmm.
Yeah. Now, once I go to browser, this browser. So yeah, so this suppose if you change your query here now, then you will get those results, right? ID equal to 10. So it is reading that Postgres database and fetching those values. Okay, so this is the application setup. The reason I have adopted Docker for this, because it is in the market, right? It is the trending thing, even though it is also a bit older now, but it will help you to learn about Docker. It will help you to learn about Docker commands. Okay, and the best part is these containers are these are like Linux boxes, correct? So once you go inside these boxes, you need to run Linux commands, right? So you will also learn about how to see memory of Linux boxes, because see, your servers are all Linux based or Unix based. Okay, those are not Windows based, correct? So here we have created that setup on our local, right?
Okay. Okay. Mm.
Yeah. Now let us go inside one of the container. Anybody knows what is the command to go inside Docker? Anybody knows command?
No.
No.
Okay. Docker execute minus IT, then your container name. So I want to go inside puff demo app one bash. See, now you are inside your application server, right? All the Linux commands work here. For example, you run top command, you will get the result of top command. Okay. So in upcoming sessions, we are actually going to work on these Linux boxes. Okay, so it will be helpful since in real world as well, all the machines are Linux based. Okay, how to see uh, performance stats on Linux boxes, we are going to learn. Okay, similarly, you want to run VM stat, you'll get this. Okay, so I'm going to cover everything. What is the meaning of this props, memory swap, what all these counter means. So I'm going to cover. Anybody has ever run this command, top command on your servers?
Yes, yeah, we did.
Okay. Can anybody tell me what is these means? Load average? This can be one of your interview questions. If you say yes, you have worked on Linux, right?
Mm.
So this is a very important line when it comes to performance engineering. Load average gives three different values. Okay. The first value is what is the average in last 1 minute. Okay. The second value is what is the load average in last 5 minutes. Okay, and the
Mm.
third value is in last 15 minutes. Okay, now this plays a very important role. Why? Let us assume one scenario wherein you get load average. The last 1 minute value is very, very high. Last 5 minutes is very less, and last 15 minutes is lesser than last 5 minutes. Now, what does that mean? There is a sudden spike in your load. Earlier it was behaving fine, but there is a sudden spike. Okay, the scenario could be uh, vice versa. It could be something you have a very less value here than greater than 1 minute, and this could be the most highest value. What does that mean? Your system is recovering. Earlier it was having high load, but now it is recovering.
How
Okay,
do you see this
the reason
order? Sorry to interrupt.
you got your answer.
No. I didn't got my answer. You were saying something like I thought of I was interrupting you. Once you
No,
done,
no,
I
no.
will
Tell
ask
me.
you.
Yeah, that's what I was saying. If you find these values are getting decreased, decreased means there is a sudden spike. Earlier it was fine. And if the value is in increase, I mean, this is lesser, this is higher, this is more, this is the most highest, then that means it is recovering. Earlier it was high, but it is lesser in 5 minutes and less least in the last 1 minute. Yeah, yes, you were asking something. Please go ahead.
Was asking in the order. Now it has been ordered. Like for example, like you said, like it initially it was 5, 10, and 15 minutes, right? Like the first one is a 5 minutes, second one is a mid
No,
value.
no.
Uh,
First one is 1 minute,
oh, sorry, 1 minute, 5 minute, and 10 minute. Okay, so
15 minute. Yeah,
15 minutes. Then I have to
yeah,
look in the backward side, right? First, I have to see in the 15, 10, and the last is the 1 minute, which should I
correct.
come from the right hand side, right? So, okay, usually we used to see it in, okay, got it.
Yeah,
Mm,
yeah. This thing remain like this only. I mean, first
mm,
value will be your last 1 minute. Second will be your last 5 minute. This will be your last 15 minute. I remember somebody asked me this question
mm.
in my interview somewhere, so that is why I thought I will share it with you.
Okay, what it is showing is like CPU memory, right? CPU usage, whatever we are seeing here. This is
Yes, this is CPU, correct.
sure. Okay.
So it is, yeah. So it will just give you a pattern whether you
Mm,
are in recovery mode or
mm,
whether you are in exhausted mode,
mm,
right? So how many total CPUs you are running currently, users? I'll come to this later,
mm,
but I just want to show you. Since we will be working on Docker, so it will be very beneficial upcoming sessions. So please do not miss those. Similarly, if you now you want to come out of this, let's say just enter exit, and let's say now this is a container ID. Okay, this is a container ID, and you want to see, let's say, IDs of all those containers. You can run simply this command docker ps minus a. Okay, you will get all those container IDs, image names. Okay, when it got created, what is the status, what are these ports, and what is the name. Cool.
yeah, cool.
Any questions so far on this?
Yes, good.
Okay, so what we are going to do in upcoming sessions, we will be utilizing this. So I'll be sharing this whole structure with you on your Gmail IDs. Okay, and we'll start doing hands-on things. So till now, whatever we have discussed theory, right? What is JVM, what is garbage collection, blah blah blah. But from Monday, we will be doing actual hands-on. We are going to create, like I mentioned, create some faults. First, we'll run a simple vanilla scenarios, then we'll create some faults, see the differences, and all those things. Okay.
Yeah, sure. Okay.
Yep. So that is it for today, and let's connect on Monday.
Yep. Thank you.
Thank you.
Yeah,
Bye.
thank you.